Hello. So, we will continue our discussion on cloud computing. Today, we will discuss and show a demo on a open source cloud, which is OpenStack, one of the very popular open source cloud. So, we will initially we will have a some brief overview of OpenStack, then we will show a demo on OpenStack, right, that how a OpenStack can be configured, VM can be provisioned. Primarily we have used this OpenStack for IaaS type of cloud, infrastructure as a service type of cloud, that we will demonstrate today, right. So, if you see OpenStack, one of the very popular open source cloud, which you can download and install in a particular hardware configuration, even with couple of PCs with you can install a OpenStack and see the performance of a IaaS type of cloud. So, OpenStack is a cloud operating system that controls large pool of compute, storage, networking resources through a data center, throughout a data center, all managed through dashboard and gives administrator control, and while empowering their users provisioning resources on the through a web interface. So, what it says? You have a set of resources. It is a layer above those this bare metal resources, and it gives the administrator to control these resources, and the user can basically provisions VMs out of it. So, it is it acts as a IaaS type of cloud, and as it is, as we mentioned, it is a open source. So, you can download and install and give it provision of the things. Incidentally, in IIT Kharagpur, we have done experimental, we have made a experimental cloud called Megamala, which is based on OpenStack, and which has been installed over Blade server. But nevertheless, OpenStack you can install over PCs. Here also we have tried with PCs, etc., for small student projects. So, it gives a feel that how a particular infrastructure as a cloud works, and also how you can work on those things. So, as far as the OpenStack capability is there, so it has the capability of all the services, though primarily we use more as the infrastructure as a service. So, at the infrastructure as a service, provision compute, network, storage at the PaaS level, on top of IaaS Cloud Foundry, and over the as the SaaS level, that browser or thin client accesses, right. So, these are the whole pyramid of typical cloud services which is accessible over internet. So, infrastructure as a service, where you have physical servers like CPU, RAM, storage, data center networks, etc. Over that some developer service, and over that some software as a service. Now, if you look at the capability of OpenStack, so primarily if we look at from the point of view as infrastructure of service, so it is a VMs, it can give VMs on demand, right. So, it is both provisioning and snapshotting is possible. So, it is virtual machine on demand. It has a provision for networking, right. It has a provision for networking. It has storage for VMs and arbitrary files, right. So, you can have storage for virtual machines and other files, and supports multi-tenancy, quotas for different project users. User can be associated with multi projects and a type of things, right. So, in a sense it gives you a full fledged experience of a cloud, and as it is open source, you are installing. So, you have the control, both administrative and physical control over the whole thing. So, the hardware is yours, and you are running on the things. So, it is a good thing, or it is a very popular thing for individual user or group or lab to install and have a live experience, and extremely useful for students with couple of PCs or even a couple of laptops to you can install OpenStack and see that how things are there. As we mentioned earlier, that there is a good amount of research going on resource management in cloud, resource management, power management, and right, people are talking about green cloud and sort of things. So, this sort of lab scale implementation of open source clouds may help in having experience and experimentation of different type of parameters on the cloud. So, OpenStack is one of the very popular such a open source cloud. So, if you look at a history of the cloud, history of OpenStack, it started with a collaboration between NASA and Rackspace, and over years it has gone through different project mode, and you can see that it started with around 2010, and we are we are having releases, regular releases with over years. So, if it is if you see that it started with a project called Austin, and going to that Neutron and Pike and Queens, which have to be declared. So, if we look at the overall architecture of OpenStack, there are a couple of components, like one is that Horizon, which is primarily the dashboard, which emulate the dashboard, Project Horizon. So, Project Neutron, which is mostly the look at the networking, Cylinder, which primarily look at the block storage of OpenStack, Nova is the compute, Glance is the image services, that different type of different image services which can be hosted in the OpenStack is there. Then we have other things like Swift, which is object storage, like we have Cinder as block storage. So, object storage is Swift. Then Telemetry, which is the telemetry services. Keystone is the entity services. And so, what we can see that this all different sort of services which are required in a typical cloud are there in OpenStack, right. So, though they developed in different project mode, but it comes as a bundle, and we can have when we have installations, we have all this flavor into the things. So, it is a good to have a feel of the cloud, and you can have operational cloud using your own internal or in-house cloud using this type of open source things. So, it is less costly, you have to pay for the infrastructure, and if you have abundant infrastructure as means already present, or excess infrastructure already present, or which we can deploy it into the using OpenStack or any other open source cloud. So, if you look at from the other point of view, then you have the standard hardware at the backbone, then the OpenStack shared services, and over that we have compute, networking, storage services, right. And so, this, and then the OpenStack dashboard and the services we talked about. So, the user applications come from the top, and it goes on to this overall in form of APIs, and utilizes these different services to execute particular or realize particular job. I would like to mention here that we have taken most of these resources from again OpenStack site and other resources. So, these are the things which you can get in the internet also. So, if we look at the major components as we are mentioning here, if you just go back like Horizon, Neutron, Cinder, Nova, Glance, Swift, Telemetry and Keystone. So, these are the major components. So, we will just have a brief overview of these components before we see a demo on those things, right. So, one of the major critical components compute, which the service is compute, and the project is a Nova project. So, manages the life cycle of compute instances in a OpenStack environment, right. It manages the life cycle of a compute instances in a OpenStack environment. Responsibilities include spawning, scheduling, decommissioning of virtual machine on demand, right. So, it primarily work with this VM scheduling, VM spawning, and decommissioning or releasing the virtual machine on all on demand, right. So, if you look at it, manages the whole compute cycle. So, if you see that there are different type of flavor for VMs with different configuration in a typical cloud environment. Here also we can have different flavor of VMs. So, when user request that through the dashboard, the control manager or the controller of the cloud can allocate different VMs to this different to the user based on the requirement. So, it comes with a storage, ephemeral storage and a persistent storage, which can be associated with these VMs, right. So, these are possible using this compute or Nova services. Another aspects is the networking. Another major service is the networking, which is under the Neutron thing, enables network connectivity as a service for other OpenStack services such as OpenStack compute and other things. So, if we have other OpenStack services like compute or Nova storage services and so this Neutron or the networking, it provide a networking as a service to this different component of OpenStack, right. So, provides an API for users to define network and attachment to them, right. It provides API to the users to define networks and attach how to attach the things. So, if you look at any cloud infrastructure, so two type of networks are prominent there. One is the internal network, which is internal to the cloud, and there is the external network which is external to the cloud, right. So, like as we are talking about that, we have a open source cloud in our institute, that what we call it Megomala, a experimental open source using OpenStack with a very only experimental cloud, which are being used by faculty and research scholars for their computing, primarily the computing needs. It comes with different flavor. We will show that example and how we do. So, it has the internal network, right, internal network for the cloud, whereas the external network for that cloud is basically the IIT network, right. So, as it is a in-house cloud, so this is not accessible from the external world. However, the cloud itself has a internal thing which is for compute, which is for communicating between its different component and providing services, and an external link which gives a connectivity to the external world. So, this based on this Neutron type of services if you are using OpenStack. So, it has a pluggable architecture that supports many popular networking vendors and technologies. So, that is it is interoperable between different networking vendors and technologies. So, that is feasible in OpenStack. The next one is the storage service, which is comes under Project Swift. Store and retrieves arbitrary unstructured data objects as a RESTful HTTP based API, right. So, it is a stores and retrieves unstructured data objects as a RESTful I believe that you understand about the RESTful services, RESTful and HTTP based API. So, it is highly fault tolerant with data replication and scale out architecture. Its implementation is not like file server with mountable directories, etc. So, it is basically a fault tolerant system with a scale out architecture. It is not a simple file server. So, it is much more than that, and in this case it writes objects and files to multiple devices, ensuring the data is replicated across the server clusters. So, in order to make fault tolerant, it writes into the things. As if you remember, when we are talking about data on cloud or data services on the cloud in our lecture, or when we discussed about those. So, the replication is the scenario we have discussed is the three replications, right. So, it replicates the data into 3 places. So, whenever there is a write operations, all these write will be having should sync with all the replicas, whereas in case of read operations, in any of the replica can respond to the things. Nevertheless, the storage service of Swift also provides such means fault tolerant services. So, another type of storage service is your block storage, which is provided by Cinder, provide persistent block storage to running instances, right. So, it is a persistent block storage to the running instances. It is pluggable driver architecture facilitate the creation and management of the block storage. So, it is a again it is a persistent storage and persistent block storage, and provides a pluggable driver architecture to facilitate creation and management of block storage things. Then another component we are having, which is not directly under compute or storage, but plays a vital role in realizing the cloud, is the identity service, right, or what we say Keystone, under the Keystone project, right, provides authentication and authorization service for other OpenStack services, right. So, it is a identity service and provides authorization and authentication of services for other things, provides a catalog of endpoints for all OpenStack services. So, also it along with that, it provides a catalog of endpoints of OpenStack services, that where how those services are defined and type of things. So, the next component is glance, or what we say that image services. So, it basically OpenStack supports separate type of images or image services, which can be loaded or which can be instantiated into that different VMs, right. So, I can have different VM and different images of say operating systems and other things can be instantiated on the different VMs based on the user needs and requirement. So, this sort of services are provided by this glance project or the glance service, glance image service. So, it stores, retrieves virtual machine disk images, right. So, the VM disk images are stored and retrieved by this glance, and OpenStack compute makes use of during the instance provisioning, right. As we are mentioning, whenever the OpenStack have instance provisioning, then they use these storage services. Like you can have this image services. So, like you can have different images say for operating systems, right. So, you can have different flavor of Unix or other operating systems, and when you instance based on the requirement of the user, those are instantiated by these compute services. So, these images image repositories are there in the OpenStack. There is another service of telemetry, which is Cielometer, monitors and meters the OpenStack cloud for billing, benchmarking, scalability, statistical purposes, right. So, this is important for overall metering of the cloud services. As we have discussed in our initial lecture, as we understand that cloud is a metered service. That means, whatever uses and type of things are metered, right. So, that means this particular Cielometer or the telemetry services is in cloud in OpenStack helps us in monitoring and metering the OpenStack cloud for billing, benchmarking, scalability, statistical purposes. Not only for metering, it is required that as you are having this measured services. So, you can do benchmarking, address the scalability issues and statistical analysis, like you want to know that what is the loading, how it behaves and type of things. So, those type of things are available. So, it is though it may not be directly contributing to the compute or storage or networking, which usually we think that this is the major component which allows us to work on those allows us in this aspect, but nevertheless it plays a vital role in having in helping in realizing this metered service of the things, along with statistical analysis or statistical measurement of the things to judge the performance of the things. This not only help in billing of the resource uses, also it helps in understanding the future requirement and how the infrastructure at the backbone need to be increased and type of things. It help in realizing those requirements also, and maybe the trend, maybe the periodical requirement. I can say that every Monday this is the load, weekends load is less, however sometime it is some particular time, etc. So, this overall for analyzing overall this performance of the things, what we require is more about different sort of data which this telemetry service provides us. Then we have the component of OpenStack dashboard, that is what we say under Project Horizon. So, it provides a web based self service portal to interact with underlying OpenStack services, such as launching an instance, assigning IP addresses and configuring access control, right. So, it is a dashboard under Project Horizon provides a web based self service portal to interact with underlying OpenStack services, such as launching instance launching, assigning IP address and configuring. We will show in our demo that how we are using this OpenStack dashboard to user management, to resource management. Like we want to assign a VM or assign IP address, or even configure the access controls, loading images, etc. all can be done using this dashboard. So, it is also important aspects, and it is the what we can say front end interface for the administrator to manage the cloud. So, it is extensively used for management of the cloud. So, if we look at the overall architecture, then what we see that we have different components, right. So, this is OpenStack object storage, as we have discussed, that is which is realized through Swift, that OpenStack image services which is realized to Glance, OpenStack compute services which is realized to Nova, nearest by Nova. There are block storage which is Cinder, OpenStack networking which is the Neutron, right, and OpenStack identity services which is the Keystone, right. So, there are different type of services, and we have seen that Horizon which allows us to look at the dashboard. So, this is that OpenStack dashboard, and this is the internet that user comes from the command line interfaces Nova, Neutron, Swift, etc. Cloud management tools like RightScale, other tools, GUI tool, dashboard, CyberDuck, and so on and so forth. So, there is the user interface for the things, and then it basically based on its requirement it hovers into the things. So, there it shows that over how this overall at the top level OpenStack modules are interconnected, how the process flows goes on into this OpenStack module, right. So, this is the overview of the thing. There are a few more sites of the individual component. We will not go to the much nitty-gritty of the things, but nitty-gritty of the material, but try to see that what are the different type of components. Like if we look at the OpenStack workflow, so these are the different components are there. Nova for compute, Cinder for block storage. These are the compute nodes in the Nova. There are other components within the Nova. there is a Cinder also have its own component. Neutron is the networking part, networking aspects. So, Neutron API, scheduler, plugin, queues, etc. These are the all networking related component. We have Telemetry, which is primarily that the metering service or the telemetry component, and there are keystone for the identity services. So, user logs in to UI specific VM parameters like name, flavor, keys, etc., and hits the create button, right. So, they do it on the means when the user logs in with the particular creating a VM. Then the horizon sends the HTTP request to keystone, authenticate information specified in the HTTP header. So, horizon or the dashboard service sends the information to this identity service. Then we the keystone sends the temporary token back to horizon via HTTP, and Nova API sends HTTP request to now after that keystone sends the HTTP, then the keystone sends the temporary token back to the horizon via HTTP. Horizon sends the post request to the Nova API and send it. So, once that authentication is there, then the horizon sends the things to the compute server, which in turn does it other operations. Now, finally, the Nova API sends HTTP request to validate API token to keystone, right. So, this way the whole thing goes on, and if we look at the token exchange mechanism. So, the user to the keystone, it is the for the identification and authentication, then it goes to the Nova, then the glance and the Neutron. So, this is the what we say if we look at that process flow of that particular token authentication token uses. Similarly, there is a provisioning flow. Nova API makes a RPC cast to scheduler, scheduler picks up the message from the message queue, scheduler fetches information about the whole cluster from the database filters, selects compute nodes, scheduler publishes message to the compute queues, Nova compute gets message from the message queue MQ, and Nova compute makes RPC call to Nova conductor, and so on and so forth. So, that is the how that provisioning is made into the OpenStack, right. And then we have individual component like compute driver, which are expansion of the things. We are not going detail into the OpenStack things. Those who are interested in particular things can refer to their resources. Similarly, we have Neutron architecture, which is the networking architecture, and as such Neutron also have several components into the thing into under its folder. The glance, which is for image service. So, it has a glance databases, can register that what sort of services are there, then glance API and storage adapter. So, we have again a few components under the glance. Similarly, Cinder architecture, which is for block storage. So, these are the major component of the Cinder, that is Cinder databases, scheduler, API, volumes, and a backup service of the Cinder. Keystone, as we have already discussed, is the identity type of service, and it has different modules or different components: policy backend, tokenization, catalog service, identity service, assignment backend, and credential backend. So, these are the different type of component or services under this Keystone identity service. So, if we look at the OpenStack storage concepts, it is in the similar line with the other cloud storages like ephemeral storage, persistent till the VM terminated, accessible from within VM as local file systems, like this is the ephemeral storage. So, once the VM is terminated, it also goes off. Used to run operating system and or space, like as it is ephemeral. So, it is primarily used to run operating system which are loaded as and when things are required, and it is also can be used as a cache space and managed by the NOVA that we have seen. Block storage persists until specifically deleted by user, right. So, it is a block storage. So, it persists until specifically deleted by the user, accessible within VM as a block service, right, used to add additional persistent storage to VM and to operating system. So, it is a used to add additional storage to the things, otherwise you are with the VM ephemeral storage only, and it is managed by Cinder. Then we have a object storage which is managed by Swift, persist until specifically deleted, accessible from anywhere, used to add and store files including VM images, right. So, these VM images which are managed by some of the images managed by the glance services are also used to add store files into this into the object storage, and the object storage is managed by, as we have discussed earlier, is by Swift. So, in summary, if we have a quick overview of the whole this OpenStack, the user logs in Horizon and initiates the VM creation, Keystone authorizes it, NOVA initiates provisioning and saves state to the database, NOVA scheduler finds an appropriate host, Neutron configures the networking aspects, Cinder provides block devices, image URI is looked up through glance, image is retrieved via Swift, and VM is rendered by a hypervisor. So, this is in a overall that a brief overview of this OpenStack open source cloud. So, what we will do next is a demo on these things. We will try to give a live demo of our OpenStack installation at IIT Kharagpur, as I mentioned, and then we will see that how VM can be created and all those things. Thank you.